Alright, let's talk about something that, in Google DeepMind's own words, is a significant step toward artificial general intelligence. We're referring to Sima 2, the new AI agent that thinks, acts, and learns in 3D worlds and can improve on its own without constant correction. What is Sima 2 and why does it matter? Sima stands for Scalable Instructable Multi-World Agent, a scalable, teachable agent designed to operate across multiple worlds. The first version of Sima was the first serious attempt to convert natural language instructions into actions within video games and 3D environments. Sima 1 could follow basic commands, turn, climb ladders, open maps, but it didn't go much beyond that. It didn't seem to truly understand what it was doing, but with Sima 2 the story changes. Now people can reason about their goals, talk to us, explain what they're trying to achieve, and most strikingly, improve themselves over time without direct human intervention. All this happens because Sima 2 integrates Google's most advanced Gemini models, which act as its reasoning and feedback brain. In this new version, Sima 2 isn't just executing commands, it interprets our goals, breaks them into steps, chooses actions in the 3D world, and explains what it's doing and why. Google describes it as an interactive gaming companion, not a clumsy bot that just obeys, but an agent that understands context, evaluates options, and makes decisions. Additionally, thanks to Gemini, it greatly improves generalization capability and reliability. It understands much more complex and nuanced instructions, and completes them even in games it was never trained on. This is key when discussing more general artificial intelligence. It's not about excelling at one task, but adapting to many different situations. Looking at the data, the leap is enormous. In evaluation tasks within 3D environments, Sima 1 had a success rate of about 31%, while Sima 2 reaches 65%. The human benchmark is around 75%. This means Sima 2 is just a few points behind an average human player in these specific tasks, and impressively, this improvement came in just one generation of development. In previously unseen environments, Sima 2 consistently outperforms Sima 1 by a wide margin. It generalizes better, completes more tasks, and navigates new worlds much more effectively. One of Sima 2's most important capabilities is that it doesn't just memorize, it can learn new concepts and reuse them. Additionally, the next step is even more striking, combining Sima 2 with Genie 3.0. Genie 3.0 is a world model that generates interactive 3D environments from a single image or text prompt, and maintains consistency for several minutes. We can navigate this world, modify it, and the system remembers what happened. It has environmental memory. When Sima 2 is placed in these newly created worlds, something powerful happens. People have never seen these environments before. Yet it manages to orient itself, understand our instructions, and take reasonable actions to achieve objectives. In other words, we have a model that generates worlds and an agent that acts within them. And Gemini, providing vision and reasoning capabilities, is an AI agent playing, exploring, and learning inside a world that doesn't exist. Furthermore, what makes Sima 2 especially interesting is its capacity for self-improvement, and it has an initial phase with humans, then a self-learning transition, and finally uses Gemini as an internal coach. Its own experiences become training data, with every attempt, success, and error saved as experience. Although Sima 2 currently exists in virtual worlds, the implications extend far beyond gaming. In the real world, robots need to understand physical spaces, navigate changing environments, manipulate objects, follow instructions, and maintain goals through multiple steps, similar to what Sima 2 practices in these 3D worlds. The idea is to train most of these skills in simulations and AI-generated worlds that are safe, inexpensive, and virtually unlimited in variety. Current limitations for AGI mean it's far from perfect, still makes mistakes, has limited long-term memory, and sometimes shows incoherence and strange environmental changes in generated videos. Even so, its combined capabilities are what transforms it into something truly significant. We're not at AGI yet, but looking at the leap from Sima 1 to Sima 2, from an agent barely completing simple tasks to one approaching human-level performance in many cases, generalizing better and training itself in generated worlds, we see key pieces coming together incredibly quickly. If this pace continues in future versions, we're likely approaching general autonomous systems capable of functioning in both virtual and real worlds much faster than many anticipated.